draw using electron dot structures the formation of sodium chloride. Elements: sodium and chlorine. Okay, you draw an arrow showing where that electron is going to go. So that sodium atom is going to donate its electron to chlorine. So you're going to end up with 2 ions. Because sodium gave up its electron, it no longer has any dots. It lost, so it's positive, and it lost 1, so it's 1 positive. So you put the square brackets and the charge. This is way nicer than having to draw board diagrams. It's just the winds. Okay, chlorine. Chlorine will now have its octet filled. It has all of them. It gained 1 electron, so it is 1 negative. What you have just drawn is show using Lewis dot structures how sodium chloride forms. No. There might be one in the freezer part. Okay, so this is how it forms. If I ask you, draw using electron dot structures the structure for sodium chloride, if I ask you just to draw the product, I'm asking for just this. Oops. Lewis. So if I say draw the Lewis structure, you're just going to draw the product part. If I say show, you're going to draw the whole thing. You're not going to keep any behind. You want to give up all your valence electrons. Fluorine wants to take one and fill its valence shell. So calcium can give up an electron to fluorine, but then it's still got one. So you need 2 fluorines. Okay, so now calcium has given up both its valence electrons, so it has none. So now it has a +2 charge. Fluorine only took one, so it's still one negative, but we had to use two of them. So you can put the two here, or you can draw two separate fluorines.
Why is there two F's?
Because I had two electrons to give up, but only one, fluorine could only take one of them, so you need two fluorines. So, when we talk about ionic compounds, we don't talk about molecules. Like covalent compounds, we say we have molecules of carbon dioxide, molecules of water. When we talk about ionic compounds, we're talking about formula units. The smallest whole unit that represents that compound. So that will be the chemical formula for that compound, like sodium chloride, NaCl, calcium fluoride, CaF2. Crystal lattice, so there's a regular arrangement of ions in 3 dimensions, and they form a very organized lattice structure, so repeating units in all directions. Ionic compound properties, they're all solids at room temperature. They can only conduct electricity if they're melted or dissolved in water. And if you conduct electricity, if you're dissolved in water, you're called an electrolyte. They have very high melting and boiling points, so that tells you that ionic bonds are very strong. The stronger the bonds, the higher the energy required.